Welcome back to our live training session. We're going to be taking a look in this training module at doing a cold start warm-up enrichment tuning process, as well as taking a look at our acceleration enrichment fueling. Now, before we jump into the tutorial, talking about what we're going to change and the things that we need to take a look at in data logs, I first want to go over some changes that I've made within the vehicle here and some change I made in the software to correct the problem that we're having. So the easiest thing to talk about here is going to be the flex fuel sensor. So we know in the third training module we fired up the engine, the flex fuel sensor was kind of erratic, going all over the place, bouncing between 9-10% to 100, back again, and it actually was throwing a fault, and it was going into a fail-safe alerts, or the safe alert down here. If we go down, I had it under our general alert settings. It was going into our safe mode limiter because I had it set here so that it would flag if there was a problem with the flex fuel sensor, and it was actually hitting that limiter, creating all kinds of problems for me when I was doing some part throttle driving in the fourth tutorial. And so I turned it off and I disabled the flex fuel feature because it wasn't reliably working. Now, this vehicle has been used for probably 8-9 different standalone systems, so it's our in-house demo vehicle for a lot of the training tutorials. I've used it with Motec, Link, Haltech, Max ECU, Mtron, the list goes on and on. I haven't had a single problem with the flex fuel sensor the way I have wired it into the vehicle, which was going to be 12-volt power supply, and then a chassis ground, and then the signal I've always fed into whatever the input I want to bring in for the standalone system I'm working with. It's never caused a problem. Now with Fuel Tech, it's a different story. What I found was that the chassis ground was creating the noise problem with the Fuel Tech. I simply moved the flex fuel sensor from the chassis ground to the signal ground, which is the green and black wire on the Fuel Tech. That's where all the 0 to 5 volt sensors are grounded to, as well as your temperature sensors. I moved it to that specific location, no more issues. So we're definitely gonna be able to do a flex fuel tutorial in the next training module. We'll be looking at that process, but we'll find that the flex fuel sensor is reliably reading now. So for whatever reason with Fuel Tech, you cannot chassis ground the flex fuel sensor. Other standalone systems specifically call out that you chassis ground the sensor and that you don't sensor ground the sensor. So it's going to be the difference of hardware between different standalone systems, but that definitely threw me for a loop. So that's been corrected, and we'll find everything should behave normally now. But we're not doing flex fuel right now, but I did want to mention that as I was coming in here. Now, the other thing that we were finding in the FT logger software, we were looking at the logs, we were seeing the units were in metric units. So not air fuel units, but lambda. Not Fahrenheit, but Celsius, not PSI, but bar. So what I found is there's no way to directly convert, at least that I can find in the FT logger software, for the units to go from standard to metric or metric to standard to simply right-clicking on the sensor and trying to select a different unit scale like most every other logger software that is for their standalones on the market. This is a little bit different. You have to make sure in your interface settings here that you have your measurement units set to what you want to display, not only on the actual display screen, but what comes through on the logging units when you're pulling the logs out of the actual the Fuel Tech. So we can see right here, it was previously set to bar, Celsius, lambda, kilometer per hour. So on some of the other settings, these were all set to metric settings. Now, I simply went in here and toggled on what I want to see. So PSI, Fahrenheit, air fuel, mile per hour, on and on. So units that are more familiar with most people in the United States. Obviously abroad, you're going to be more used to working in metric units. It's going to make more sense. So that's going to be one of those differences that we want to make sure before we start logging that we go ahead and we change. It's been a little bit since I've used Fuel Tech, so I probably forgot that had to be set up, and that's what was creating the problems when we were checking our data logs. No big deal. The data was still the same. It's just that unit scale wasn't exactly what I wanted to see it in. Now, we have this set correctly here, so everything should line up properly in our logs, and we're looking at our cold start now. All right, so let's talk about where we're at for the cold start. So let's jump up here into our main fuel table. So down here below, we can find that ambient air temp is about 49 degrees. The actual engine coolant temperature here is about 52 degrees. They're fairly close to each other. 2-3 degree deviation is normal for the temp sensors, so we know they're both calibrated. The engine is cold. In fact, I haven't filmed for a few days, and the garage is pretty cold right now. It's not heated in here. So we're going to be firing off the engine when it's bone cold. Things drastically change for a cold engine from a warm engine, specifically when we're going in and we're spraying the fuel into the engine. When the engine is cold, the fuel as it comes out of the injector does not atomize. very well. It atomizes, but not very well. And as a result, it's going to stick to the intake tract, to the intake valve, to the intake port. So each engine cycle, where we normally would ingest most of the fuel into the engine in that engine cycle, now we're going to have a 20, 30, 50% reduction in what amount of fuel actually gets into the engine within that cycle as it's drawing in the air and the fuel mixture. As a result, we need to offset it. So we need more cranking fuel. We need more fueling when the engine is coming up to operating temperature. We also have to have a higher post-start fuel correction. So the post-start fuel is used for the first few seconds after the engine's fired off so that we get stable combustion and the engine continues to run. So all of that needs to be increased to overcome this wall wetting effect that's in place. So we use a couple tables to account for that. Let's go and talk about those specific tables, because this is going to be part of the fuel correction that we need to make, these tables, for specifically a cold engine. Now, warm, we know the engine was cranking off, it was idling fine, it was running fine. It's specifically in this cold situation. So we have a prime pulse table, which I'm not going to change. Prime pulse table is used for the first cranking revolution as we're cranking the engine over. So this is a really big shot of fuel to prime up the combustion chamber. Then it switches over here to our engine start or the cranking fuel table. We can see this is based on coolant temperature, and we know when the engine was warm, 6 milliseconds seemed to be pretty reasonable to get the engine to fire off and run. Now we do have that goofy starting problem, and that's just specifically a power distribution problem through the main relay, through the harness. It gets weird when I'm trying to start it sometimes, but it does start up and run. Sometimes it starts up perfect. Now, when we're cold, we can see here a value of 12 milliseconds is not going to be enough. Simply, it's not going to be enough. Now, I have a pretty small injector. I have an RDX 410cc injector. We're probably needing around 20 to 30 millisecond for our cranking fuel with the smaller injector. Now, if you're on really big injectors, 2000cc injectors, you may be able to get away with something like 8 to 12 milliseconds. Smaller injector, we need a higher pulse with under cranking to deliver the same amount of fuel flow into the engine. So this does not scale for when we're setting up the fuel tech. It's not like a VE-based airflow modeled system like other standalone systems where if we put in all the data, it's calculating airflow, it knows the injector size, it can deliver appropriate amount of fuel based on your injector flow. It's not the case with the fuel tech. We actually have to put a value in here that makes sense for the injector size that we're working with. Smaller injectors, bigger amount of fuel in our table here in a cold engine. I'm going to go here and change this from, let's say, 12 to something like maybe 24, 26 milliseconds, just kind of a guess. I'm going to almost double that. And then here at 14 degrees Fahrenheit, I'm going to go ahead and make this something like 40 millisecond. And then between these two, I'll do H, I'll interpolate, and then I'll interpolate downwards here. 50 to 104, we'll just do H. We'll bump that up as well. Warm cranking, we're good. Cold cranking, we're definitely going to go ahead and increase that. Now, we also then have our post-start enrichment. We can see here 0 seconds is when we exit the cranking threshold, which in this case is set at 400 RPM. If we go down here and we look at our engine settings in our fuel injection, we have, no, actually back in here to engine setup, I'm sorry. RPM for engine start. 400 RPM is the threshold. 400 RPM and below, we're using cranking fuel, cranking ignition, cranking airflow for the idle control or for the airflow for the drive-by-wire, idle control, whatever. The idle control motor, whatever you're trying to control for idle. That's going to be what its source is. Now above this, it goes into the normal run tables. So main fuel table, main spark timing table, main idle airflow tables. But this is that threshold, that's that balance. So below this, it's using the cranking tables. Above this, it's going to start to kick in here to the normal main fuel table. And then the post-start enrichment, the 0 second timer starts when we exit that 400 RPM threshold. So we go higher than that, immediately goes to the post start. Then it starts to apply our fueling correction here. Now it only does this for a few seconds. We can see it ends here right around 8 seconds. You absolutely want to make sure on a warm engine that what we find here is zeroed out. So this column, 122, 176 degrees Fahrenheit, we want to make sure that this is 0 because this will add against the main fuel table and always have a percentage correction, kind of like a main overall fuel trim. We have our overall fuel trim here. We don't typically use that. We scale out through the main table. That's going to be what that acts like if you have a value populated. You can see here, my values are zeroed out. Now, once it's exited the post start after a few seconds, it's going to be then running on the main fuel table. So it's always running on the main fuel table. It's going to be not using any post-start correction or enrichment. It'll be utilizing then our engine temp compensation. So it's going to be adding this percentage of fuel increase against our main fuel table. Now, when we have the engine firing off, it exits a cranking threshold, it goes into the normal run routine, it goes into the post-start, obviously using the main fuel table and the engine temp compensation. These are all in play at the same time. So they're going to be increases, percentage increases. So if we have 100% between the post-start and the warm-up at the same time, 100% increase, that means the injector pulse width is doubled. So if it's, let's say, 8 milliseconds or 4 milliseconds when the engine would be warm, it's now going to be corrected to 8 milliseconds. And then it tapers away against that time in the post-start here. Again, that kind of tapers that away. Then we're left with engine temp compensation as being more of the long-term fueling adder as the engine is coming up here. And we know when we get here at about 140 and warmer in the coolant temp, we zero the table out.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.